Okay, let's talk about lambda functions. Now, a lambda in Kotlin is defined as the following, and these can look very confusing the first few times you see them. So if we're going to build our own lambda function so you can understand what they are, and basically lambda functions are functions that are, I'm not going to get really mathematical about you and higher order functions and everything like that, though I really advise you go read the documentation. Lambda functions are basically little functions that you can create and start passing around inside of your application. It allows you to be very functional in nature. So enough of that, let's get into a implementation. So a lambda is defined as having a name of a lambda, and then you have its input types, which are going to be the parameters that are passed in, and then it's going to have a return value, and then inside of that you're going to actually have some code, some arguments that you get to provide the names for, and you have to provide their types. Again, that's going to be the input type over here. So we can go ahead and change this to input type so it makes more sense. Input type, and then you're going to have the body of your actual lambda function, which does its work. Now, a lot of type inference will happen with this, which we can get into in a second. But let's go ahead and create our first one. And the first one we're going to call is the end result. Is what we want to be able to do is say greeter. We want to be able to do this, and I want to be able to pass in my name. And what I want to happen is I want hello Don to come out somehow. So how are we going to do that? So this is a very rudimentary example in which you could normally write a regular function for, but this illustrates the lambda functions. And so what we would say is we say val and say greeter, and we do colon, and then we need to provide the input type. So remember, let's look at our example again. We have greeter, and inside the greeter function, we want to be able to pass in the word Dawn. And so here what we need to do is say, hey, we need to pass in an input type. That input type is going to be a string. Okay, and then what do we expect the return type of greeter to be? Remember, what we wanted it to be Don Felker is what we want it to come out of it. So we expect the return type to be a string. Okay, now we need to start defining what our lambda expression looks like, our lambda function. And so in here, we actually are going to have the parameter. So our first parameter right here, which is passed in, is Don. That's a string. Let's go ahead and give it a name so we can work with it. So let's just call it name. And of course, we know it's going to be a string. So again, we have to provide it right here. That's one of the arguments, and provide its input type. And now we actually provide the code body. And so now this is the actual body of code in which we can do some stuff. So here, what we can say is hello, and then we can use string interpolation. And we'll say name. And what ends up happening is the last value that's inside of this lambda expression of this block of code is the return type. So whatever this type is going to be the return type. So if this was multiple lines, which it could be, watch, we can put these on different lines and we can have multiple lines. Whatever is the last one here, I could say val foo equals 0. It doesn't really do anything. And then we get this nice little lambda notation here. It says, hey, this is the return value of our lambda. So whatever this type is going to be the return value. So it's a string. So if I said, hey, I want the length of this string, we're going to get a compiler error because it's going to say we are requiring a string. Again, this is the return type of the lambda, but you're actually giving us an integer because this is the last line on here. We're not saying return anywhere, but by default, the last value is the value returned. So since we can single line this, we'll do that now. It's pretty easy. We'll get everything back on one line. And then what we can do is we can go ahead and execute greeter. And we'll go ahead and pass the name Dawn in. And so it looks like a regular function. And we can see here, when we did that, we created the new greeter here. We could see that it's going to take in a string. Let's go ahead and run it. And then what we're going to see is that nothing happens down here in the output window. We're expecting something to show up here, but nothing did. And the reason why is because greeter is a function that takes a string and returns a string. It doesn't do anything with it. So we actually have to do something with it. So let's go ahead and print that return value, which we could just do this too, just so you're aware. We could actually say greeting equals greeter like that. And then we could say print line greeting. And then when we run this, what we're going to see is the output finally of that function. It's going to say hello Don. So again, to kind of cover this here, we have the name of the lambda, which is coming right here, the name of the lambda. I'll do a little simple line here. So it's the name of the lambda. Then we have the input type. Then we have the return type. Then we're having the arguments and their corresponding input and the corresponding type, which is string. And then this little section over here is the code body, which comes right here. That's the code body. So that's how all that's mapping right here. So now let's take this a little bit further though. Let's say for some reason we wanted to be able to say, like we said, we have Don Felker here, but instead it's saying hello Don. So we got that wrong. So there's a bug in our code. How are we going to fix this? Okay, this actually should say hello Don Felker. Okay, well that's easy enough. We could just say hello, we just put Don Felker in there and that would work. But what if we wanted to be able to accept two different names, because in our database everything is separated out, so we need to have this greeter needs to be able to take two values. So again, we need to come into our expression and say, all right, it's going to take an input type of string and another input type of string. So it's going to have two. Think of this like when you write a regular function like this. You write function, my function, and then inside of this function you have some stuff, and it's going to be name, string, foo, whatever it is, last name, string. Well, notice how the way I like to think about it is these parentheses right here, they kind of just, it almost like maps directly to that parenthesis, kind of maps there, that parenthesis maps there, and it basically says, hey, look, there's a string here and there's a string here. And that's how I kind of visualize what these parentheses up here are. So this is going to take in some type of string as one parameter. The next type of, in that next parameter is going to be string. And the whole thing's still just, in the whole Lambda expression is still just going to return a string. Now we get a problem over here. It says, hey, we're expecting two parameters of type string and string. Remember, we're taking in two now, but over here, this is the list of arguments. Remember, this is where the list of arguments map in. And if there's more than one, then we need to put a comma here, just like we would traditionally in a regular function. So I'm going to rename this as first name, because I can name this anything I want. And then I'm going to say last name, string. And now I'm starting to run out of a little bit of room here, so I could shrink this down a little bit. But what I have over here, I need to change this to first name, and then last name. And I'll do string interpolation again. And now we have a Lambda expression that's going to take in two values. So we see right here, it says, hey, we're waiting for the second value, P2, which can be the second parameter. So I'll take in Don Felker. There we go. And I'm going to go ahead and run this again. And what we're going to see on the greeting now is that Don Felker is returned because we're passing in a string here, Don, another string for Felker. These, basically, if you take a look at how this maps, this one is mapping to this one, and this one is mapping to this one. That's how they're mapping right there. And we can see that the first string, we're calling that one first name. The second string, we're calling that last name. And then at that point, since we're inside of this Lambda expression, we have access to those variables and we do whatever we want with them. Now, if for whatever reason we wanted to do some hokey pokiness, some hokey stuff in here, we could actually do some different things. So let's go val, modified first, f name, actually first name spelled out. And what we could just say is first name dot to uppercase for whatever reason. And then we can say val modified last name. We can say last name, not owner exception. Last name dot to lowercase for whatever reason. And then we can go ahead and replace this with the two modified ones. Modified first name, modified last name. And now if we run this now, what we're going to see is that we have a Lambda expression with multiple lines. Hello, Don Felker. So we've capitalized and done different things here. Okay, that's cool. So we see that, again, the last line here is the one that's returning the type here. And that's the type that's going to be, basically this Lambda is saying, all right, look, we have a return type of string and that's mapping to right here. So string, which is right here, is mapping to this. And the last line of the Lambda expression, whatever its type is, needs to match this up here. So let's go ahead and get rid of that. So let's just say for whatever reason we wanted to say, greeter needs to return an integer value. And this could be the number of characters inside of this greeting. I don't know, for whatever reason. We've changed this to integer, which means now that this Lambda expression needs to return an integer. But down here, the last line is what's going to be returned, and last line is returning a string. So this is not going to work. So what we can do is we can just go over here and maybe just return the length of this name. If we run this, now what's going to be returned, it's still going to take in a first and a last name, and it's going to add, it's going to concatenate hello on there. But then we're going to grab the length and we're going to print the length. That's what greeter is going to do at this point in time. Okay, that sounds cool, but maybe that's not what we really want. So let's take this back to string. Now, let's assume that we really like what it does, but we just want greeter to actually just to display the greeting. So we don't want to have to do this. We don't want to have to print this. We just want, as soon as we call a greeter, to automatically just print line, hello, Don Felker. So how can we do that? Well, this return value is what is going to be returned from the Lambda expression. So we can change that to unit. Unit is basically like void in Java, which means, hey, we're not going to return anything. We're just going to do something, but we're not going to return any value. So here we're just going to go ahead and return unit, which is nothing. And then what we can do here is we can say print line inside of here, and we can just do that. And then what's going to happen now when we run this, what we're going to see is we're going to call the first name, the last name. It's going to be passed in, and then we're just going to print line. There it goes. Hello, Don Felker. So we can do all different kinds of stuff. And this could be multiple lines, could be hundreds of lines. Of course, I don't recommend that for, you want to make your code easy to read and so forth. Because Kotlin has type inference, you can actually clean this up quite a bit. We don't need a lot of this stuff in here. So what we can tell Kotlin is, because Kotlin can look inside of this Lambda expression and say, well, we know we have one parameter, we know we have another parameter. Okay, so this first parameter is a string. We know the second parameter is a string. Okay, we can do that. Kotlin's figuring that out for us. And then it's looking at this last line down here, and then Kotlin's saying, well, this Lambda expression is not returning anything, so it's actually going to be, it's going to be unit. So it can infer the return type, and it can infer the parameter list. So what we can actually do to type inferences, just go ahead and get rid of that. So now we have a very succinct, or much more succinct Lambda expression. So if we want to do the simple one, so we want to do just a simple one, greet, we could have done something like this. Could have said name, string, and then we could say this, print line, hello, name. And there we have our very simple little greet. So of course we have our greeter that does a bunch of different stuff, modifies some variables, which we'll move up here just so it's obvious. And then we have the very simple version right here, greet. And if we print these, of course we got the spelling wrong. And if we print these, what we're going to see here is we have both of these printing out values. Now, your Lambda expressions are not limited to one or two or three different types. You can pass in many different types into your Lambda expressions. If for some reason when you're writing your Lambda expressions and for some reason Kotlin cannot perform type inference, you will have to provide these hints. And sometimes you'll run into weird situations where based upon something that you're doing, you're going to have to tell Kotlin, hey, by the way, here's how we're going to go ahead and do all this stuff. It's going to be, it's going to be a unit or whatever, and so forth. So you'll have to provide all the information. And this is kind of this is the blueprint up here. This is the blueprint that you just need to remember, that you're going to have Lambda name, then you provide the input type, the return type, equals whatever this Lambda is, and it's going to have your arguments. If it's going to have one to many of them, you have the body of it, etc. And that's understanding Lambda expressions.